All right, so let's look at what we can do more. We mentioned in the first video, did I start? No. We mentioned, am I streaming? Yes. We mentioned in the first video that the shield check that we were doing was doing that individually for each unit, even though we could argue that you would receive the same shields for units that are very close to each other. So instead of doing it for each unit, we are going to do something else. We are going to get all the shields here for all the units in this square. And then instead of doing this shield protecting target RNG, which is this function right here, we're going to introduce, no, for now we're just going to copy this one. There we go. And we're going to make this a local one. And we're going to add a third argument here. And we're going to say, well, shields is shields, or we get the shields around us. Which means that this is called defensive programming. Either the argument is set, so this is not nil, but if it is nil, then we get the shields regardless. So here, if target unit is dead, if unit, then we can skip. Determine if target unit is part of some shield. So now we just have to provide the shields that it would use to determine whether or not a unit is shielded or not. We still got this function right here, which is the one above. I'm just going to copy that too. In practice, Erlentor, if you're watching this, you probably want to update this function right here, add a shields parameter here, but if I resave RNG utilities, then the game crashes. Right, so considering that I've got the game running in the background, I'd like to keep that going. Do we have everything we need? Yes. Now there's this v distance 2 squared. That one is slightly questionable, but so to give you an idea, we have math generic, no, math to no. Somewhere in here we have that. Meta tables, memory, no. There is somewhere. I should really organize these better, but give or take, it's better to just do this computation in plain Lua than it is to use this engine call. But that change is so small that for now we're just gonna ignore it. It's not measurable in comparison to the change that we're working on right now. So here we have units at location, and we would also have shields at location. So we can copy this function right here. It's important we added this category, so we gotta add it here too. And target unit in this case would not be target unit but the same table that we have right here. So let's make this cached dummy table local. What were these things? Thread local vector cached is a vector 0, 0, 0. And then here we're going to populate that vector is preprocessing 1 and v2 is 0 and v3 is what we have right there. This prevents allocating that table every time. And now here we have 50 plus the scan radius, right? Because we want to, if we are scanning for this square here, we're scanning from the center, then we want to make sure that we have all the units. If there's a shield somewhere right there with a radius of 50, then we gotta add the radius of the square to, so that if we have a small Tech2 structure right here that is captured by that shield, that we increase the radius slightly, right? Because we're searching for the entire square and not for all the individual units. Okie dokie, this would be self. Category scan radius max. Did we crash it? We did not. All right. Yeah. Thread position format as used by the engine. Retrieve neighboring shields, units and shields that are in or overlap with the IMAP square. Not really sure. Cell, maybe? IMAP cell. Let's go for cell. Help us debug. Oh, right. We should probably do that first, but let's do it afterwards. And then here, let's just write this out. That makes it a lot more easy on the eyes. Not everyone's gonna agree with me on that. That's fine. I hope the game is not too noisy in the recording actually. How noisy is that? This is gonna be a good recording. Alright, there we go again. And then we have the last one. Oops. IMAP air land. Ta-da. All right. Get army index. So now here, as we want to use our own function, right? We don't want to use the one in RNG utilities. Again, Relenter, if you're watching, you do want to use the one in RNG utilities, but for our sake, we don't want to do that. Apparently I did this wrong everywhere. And we want to append the shields that we already found as an argument. There we go. Did I accidentally? I don't think I did. So the game is slightly laggy. I'm not entirely sure if that was already the case when we started out. But now we no longer retrieve the shields or look around ourselves for every single unit. Instead, we only look around for every thread, which is still not perfect because we can have 20 thread values, and the thread values can be shared given their positions. So by all means, we're not done yet, right? Because it could very well be that we have 4 threads at the same location, and for each of those 4 threads, these units and these shields would be the same. So in that sense, we're not entirely done yet. But this is already significantly better over what we had, right? We're no longer doing it for every single unit. So that's a good start. Now let's restart this game real quick. I think one issue that we have is the fact that we're running this in pcall, causing this one to run quite more often. Alright, so that is a reasonable performance improvement. Let's do some of the low-hanging fruit. The type of performance improvements that we always take into account. So we've got this math max, right? We can upvalue that. Change to add value scope for performance. So math max local. There we go. And how many of these do we have? Only one. And we have get units around point, which is already a local, I think, somewhere right here. Yep. This is a debug function. That's all fine. We've got this coroutine.yield, local coroutine yield. We're doing this quite a few times. Those are doing it anywhere else? Nope. Let's actually add started analysis. Self.nickname. I think there is a betabrain.nickname capital N, and then here at the bottom we can say finished analysis for. So now we can see the brain that started the analysis. Oh, I think it's lagging because my computer is dying. No, it's doing fine. But there's something. Right, see, so here we can see started analysis. We can go even a bit further. Let's add a time measurement to how long this analysis actually took. So we have game time, so local start time, started analysis at, and then here somewhere at the bottom we have finished. And then we log the difference time of analysis. finished minus start analysis at. Now this is gonna get quite a bit skewed because we've got these coroutine yields going on. So let's just remove those. I think Rolenter added these in to prevent stutters. But we're gonna write this so that there are no stutters anymore. And there's no need to do these coroutine yields anymore. When we're done with this, of course. And if we do that, then we also know that this fork fret here is no longer required because we're not going to be waiting in this function. So we'll just have this peak hole. So there's no... Yeah, that's fine. And then let's do a quick restart. Oh, we did a mess up. 84. Right, that's me and my keyboard. For the series, I have bought the cheapest keyboard at the electric store because there's no sound when you click on the keys. And I'm gonna get used to the fact that everything is slightly different spaced. So initially the analysis takes no time whatsoever. That is because we are using the wrong one. Sim, wrong repository. There we go. Get game time profile. Yeah. We'd like to use this one. So here we can see the time that it spends doing this analysis, which also means that the lag that we're seeing, the stutters, is not coming from this function right now because the function is way below 1 millisecond. We should have probably started doing this so that we knew what the changes are, how much they impact everything. All right, now there's one more thing that we can do, and that's particularly relevant when we have a lot of fret locations. So there's these blocks of code, and what they do is populate the air and accumulated air and land fret. But these air and land values, they're already set here, but then to 0, because they depend on these defense categories. Or no, they depend on another fret, right? So a fret block where the fret type is not structures, but the fret type is anti-air. So we got to fix that, right? Because right now we're going over all the frets again for every unit that we have, and that seems a bit meh. So there's two things we can do. Analysis is still very small, so that's good. So there's two things that we can do. One is we post-process everything, which is what Rolenter is doing right now, but we post-process it using a hash table, right? So instead of looping over all the frets, we would reformat these threads so that we can use the position as a hash, or we pre-process all the threads once and determine that hash so that we can use that to find the air and land threads when we populate the units themselves. And if we would pre-process it, then we can get rid of these, this one, that one, and that one. And that sounds good to me. Whereas this one is the aggregation of the firebases. That is another thing to look at. And this one has the same stuff in it, but It apparently also tries to scan for for something else here, where we determine whether or not it's a firebase. And we use the thread locations. We kind of abuse the thread locations here. I think this, I'm not entirely sure why this is not just that. Maybe there was a YELT here, then it would make sense. Because we are going over self, enemy intel, enemy threat locations. Something just died in the background. And that's the same thing as threat, right? Because we're using Q as key. So we can do this. But let's do the pre-processing. We are 21 minutes in. We can squeeze that right in. So what is the idea of the pre-processing? Well, we want to give every thread a unique identifier so that we can quickly find out where the additional thread values like anti-air or land units, where they are, so that we can quickly find them. I just said the same thing twice. So let's do that. We know at this point that there are thread locations, right? So let's here do a table lookup air thread, and then another one lookup land thread. Look up. And when we go over every thread, we've got this position value here, and we're going to be using that as our keys. So let's first quickly look at what those positions look like in practice. Thread is 159, insert time, enemy base radius is true. It still finds no thread. No thread. Ooh. Okay, so one observation, but I'm not entirely confident if that's always true, is that the position are integral numbers. But I'm not entirely sure if that's always true, right? We can only see integral numbers here. Let's scroll up a bit. They appear to be only integral numbers. Let's look quickly where this is populated. Position on water, no. Okay, I'm not entirely sure if we can make that assumption that they are always integral, but we'll go with it. So what that means is that we can say for each thread, if the thread type thread type is anti-air, then, and if thread type is land, then, and now we can set thread dot position 1 is a table, and then we use the second coordinate right there, which is the actual thread value, which is thread dot thread. Nice. And then we can do the same thing in here. Look up air thread, look up land thread. And we want to do an else if here, so get rid of this and because they're exclusive. And we could even improve this by reusing these tables, but we're gonna come back to them later. So now if we have the x coordinate and we have the y coordinate, then we can determine the thread value. We already noticed previously that some of these are at the same location. Let me find a quick example of that, which is by all means a lot more difficult when you're specifically looking for one. Some of these are at the same location. So we could now, for k comma x in look up air thread, do for k comma z in x, do, and then we can say thread format thread at e comma e is e, where this would be ze xe ze set. That should give us some information. So air thread, and this one would be the land thread. Right, so there we go. We have a whole bunch of land threads set there and a whole bunch of air threads. And now we can use these as a lookup table right here. So we've got the position. So now we can say, well, this air value is going to be thread.position 0 thread and thread.position or thread.position 1 or 0, right? Because it may not exist. And this one is going to be the same thing, but then land. And we can do that everywhere here. Something exploded again in the background. Because these locations of those thread values are going to be unique. That's our identifier. Now, Relentor, if you're watching this, you probably, instead of using this hacky approach where we abuse the position and consider it's the same for a thread in the same cell, you likely want to thread that originates from the same cell should have the same identifier somewhere, so that you know what IMAP grid it originates from, and then you'd like to use that for your lookup table. Because right now this is a bit sketchy, of course. So there's something in this code that is really making the game stall. I don't know what that is, but it's not our function, because that one is not even measurable at the moment. And there it is, time of analysis. But now that we have this, we can use these if air threads log string.format air thread matches we can add this little check in here for ourselves. For all of these. Oh, I noticed that Relentor is doing the same thing here, right? It's using the position and the IMAP here, but you should definitely introduce a single number that represents the cell instead of checking the position. There was an error. Image has been destroyed. Apparently this is the wrong one. How do you print a boolean in C? String format, print boolean. That's what I'm doing, right?
I get position error.
It's a what?
Did I get position error?
What do you mean?
Is it an error of trying to, of one of the, like the various move to location stuff?
No, I'm trying to format this boolean here. I thought that was this, but let's just do it the old way. It's not really do it the old way. They don't match. Nice. There is. So let's look at what we have then. Thread. Let's copy that one here too. This should be land by all means. Apparently the unit one is not set. Look up air thread. Okay, so we made a mistake. Is that what you meant, Dragon, with the position?
Yeah, I think so. If I, you know, think most often it's one of those errors come from a positioning thing.
Land thread, air thread. What does Valenter do here then? Table.equal unit.imap and the position, and the imap is the position. And thread type is this anti-air.
Hello.
Hello. Just trying to determine the values are different too. This one's with decimals. Okay, so what is the thread value here? Thread.thread. Let's compare these. Boink. Thread.position, thread.position, thread.thread. Okay, so waiting for it to show some of these. That's interesting. So we have a land thread at 144.112, but that land thread doesn't exist here, 114.176. Enemy thread locations. We're looking for the same land thread matches false. 144.144. That doesn't exist here, but it does exist there. Did I misunderstood what the code is doing? We're not. land thread, air thread, log rep threads, added anti-air thread. Let's look at what we have. We've got a lot of land thread types. But they're all recognized, so that's not an issue. Yet when we look through them later, hey, but this is the same one. We've got this one. 144. That's the same value that we have. We've got this one here too. We've got that one there too. And we've got this one. We don't have this one here. 144, 144. What's going wrong here? Why does he suddenly find this thread value the second time that he loops over it?
Maybe in case it changes.
Say again?
Maybe in case it changes.
No, there's no intermediate changes, because we populate our table here, then I don't think we do anything with thread here. Oh, hold on. This should be 1, 1, 2, 2. So that's gonna make a difference, because Lua starts at 1. Hey, this is my mistake. Still not match. Match false. All right, it's time for a break though, so let's have that break.